All right, folks, in this hopefully short video, I'm going to explain to you what a literal equation is and how to solve a literal equation. Before I do that, I do want to show you sort of a middle step into solving literal equations. Let's say that you have an equation that looks like this, a linear equation that, let's say it's 9 plus 3y minus 7x is equal to 4x plus 1 minus 2y. Okay? So it's a linear equation. It has two variables. Both variables are to the first power. It's an equation. It has an equal sign. So we've got a linear equation here, which is technically a function. And here's your task. You'll see this statement: solve for y in terms of x. So the word solve for y basically means get y by itself on one side of the equal sign. That's what solve for y means. It basically means get y all by itself on one side of the equal sign. If you saw something that said solve for p, that means get p all by itself on one side of the equal sign. If you saw something that said solve for a, that means get a all by itself on one side of the equal sign. The phrase in terms of x means make sure there is at least one x on the other side of the equal sign with all the other numbers and stuff. That's what it means. In terms of x means make sure there's at least one variable x on the other side of the equal sign with all the other numbers and stuff. So, get the y all by itself on one side, get the x on the other side, and make sure all the numbers and symbols are all on the other side with the x. That's what solve for y in terms of x means. So let's do that. We want the letter y to be on one side and the letter x to be on the other side. So here, the first thing I'm going to do is I'm going to get rid of this 9. I'm going to use an additive inverse. I'm going to subtract 9 here, and it can be combined with this plus 1. You can only do additive inverses with like terms, okay? So when I cancel this 9, I have to combine it with a like term on the other side, positive 1. I'm going to carry down the equal sign, bring down the 3y, bring down the minus 7x, bring down the 4x. Now 1 minus 9 is minus 8, and then minus 2y. Just carry that down. Now I'm going to move this minus 7x over here with the 4x because I need the x's on one side and the y's on the other side. So I'm going to do an additive inverse. Additive inverse of minus 7x is plus 7x. So I'll combine like terms. I'll put it under the 4x over here. That'll cancel the minus 7x. Carry down the 3y. Bring down the equals. 4x plus 7x is 11x. Minus 8 minus 2y. Now I need all the y's on one side, so I got to get the x's are on the right. Let's put the y's on the left. So I want to get rid of this negative 2y, so I'm going to use an additive inverse. The additive inverse of minus 2y is plus 2y, so I'm going to put plus 2y on this side. Cancel. 3y plus 2y is 5y. Carry down the equal sign, bring down the 11x, and minus 8. We're almost done. Now I got to get rid of the 5 in front of the y. It's 5 times y, so I'm going to use a multiplicative inverse, and I'm going to divide by 5. That'll cancel here, and over here I'm going to divide by 5. I'll just divide the whole thing by 5. I could also individually divide by 5. I could do over 5 and over 5 here if I wanted to. Okay? But instead, in this particular case, and either way is fine, I'm just going to do the whole thing over 5. And so my answer now is y equals 11x minus 8 over 5. I have put the y by itself on one side of the equal sign in terms of x. And I have an x on the other side with a bunch of other numbers and stuff. And so I have solved for y in terms of x. Now, I would also like to solve for x now in terms of y. So what I need to do is I need the x to be by itself and for all the numbers and stuff to be with the y. So here's what I'm going to do. I'm going to move all the numbers and stuff over to the other side with the y, but I have to use algebra to do it. I can't just move it any way that I want to do it. So the first thing I'm going to do is I want to get rid of this 5 here, this denominator of 5. I want to set the numerator free by canceling the 5. So I'm going to multiply by 5 on both sides. Multiply by 5. On this side, it's going to cancel the denominator. And I'm going to bring down the 11x minus 8. On this side, 5 times y is just 5y. Then I'm going to use an additive inverse here with this minus 8. So I'll add 8 to both sides. On this side, it'll cancel. On this side, it'll become 5y plus 8 equals 11x. And now I'll do a multiplicative inverse here. I'll divide by 11 and divide by 11 on this side. And now I have x is equal to 5y plus 8 over 11. And now I have solved for x in terms of y. So the idea here is if you have two variables or more variables, you can solve for any one of the variables in terms of all the other variables by moving all the other variables to the other side and getting the variable you're solving for on one side. Okay? So that's one thing you have to be able to do. Now we're going to move on. Now that you understand that, I can explain literal equations. A literal equation is an equation that includes letters. But instead of those letters being variables per se, instead of those letters representing an infinite number of possibilities, those letters represent one number, one particular number. We just haven't put the number in yet. And literal equations are useful so that, let's say that you keep doing the same calculation over and over again with the same three numbers from 3 different columns or something. So you take this number, and this number, do a bunch of stuff with them, and you get an answer. Then you want to do it again. So you take this number, which is, it's new this time, a different number, this number, and this number, do everything again, and you get a different outcome. And you're solving problems by doing this. What you can do is you can instead just create a formula for what it is that you're trying to solve for, so that all you have to do is plug your numbers into the variables and solve for your formula. So another way of thinking about it is a literal equation is a kind of general formula for solving a problem or for calculating something that you calculate a lot. Okay? So one way you can understand literal formulas with different kinds of, or literal equations with different kinds of formulas. One that you may be familiar with is the formula that the rate of an object is equal to the displacement or distance over time. Okay? So the rate of movement is equal to the displacement of the object over time. So another way to say it is just r is equal to d divided by t. And this, what you're looking at here, is you're looking at a formula where we have solved for r in terms of d and t. But what if I said to you, solve for t? Solve for t in terms of d and r. All that means is, instead of it being r equals, we want it to be t equals. That's what we want it to be. So we want the t by itself, and we want the d and the r on the other side of the equation. Okay? So here's what I'm going to do. I'm going to get rid of the t in the denominator by multiplying by t, which means on this side I'm also going to multiply by t. On the right side, it's going to cancel the t, bring down the d. Over here, I have t times r. Okay? I'm almost done. I just need t to be by itself, so I got to get rid of this r. Well, it's being multiplied. So the multiplicative inverse is to divide by r, and if I divide by r on the left, I have to divide by r on the right, cancel the r's, and now I have t is equal to d over r. And I have solved for t in terms of d and r. We can also solve for d in terms of tr. In fact, we did right up here when we canceled t, we had d equals t times r, and that's another, or r times t. Distance is equal, or displacement is equal to rate times time. Okay? That is solving for one variable, one letter in terms of other letters. I'm going to call it a variable because that's probably what you're accustomed to calling it. Well, we can do this with a lot of different kinds of formulas, like geometric equations. Okay? For example, the perimeter of a square is equal to 4 times the side length of a square. Perimeter is equal to 4s. Well, this is the formula for perimeter in terms of side length. What if we want the formula for side length in terms of perimeter? Well, that's easy. We just divide by 4 on both sides. And now we have side is equal to perimeter divided by 4. That's it. So if you knew the perimeter of a square, you could divide it by 4 and you would have the side length. Okay? Let's say that we have the area of a square. Area is equal to side squared. And so this is area in terms of side length. But what if we want side length in terms of area? Well, then what we would do is the square root of both sides. The square root would cancel. See, the square root is the inverse of square. That's a different kind of inverse we haven't dealt with yet, okay? But if we do the square root of both sides, we get side is equal to the square root of the area of the square. And this is side in terms of area, okay? So that's all I really wanted to show you for literal equations. This is something you have to be able to do, and I hope this helped.